I've only got one light source set up today. You'll see why in a moment when I explain what I'm trying to do. I saw a video from Big Clive that was talking about flickering of a certain kind of LED light like this, and I got to thinking about how I might visualize the flicker in a lamp. And this is what I came up with. A very simple circuit connected to the oscilloscope, and as you can see, we've got a 120 hertz sine wave over here on the scope, which for some reason the trigger's not grabbing it all the time. There's a lot of bounce around in that, but that makes sense because the light over here, I'll poke it into the shot a little bit, is a fluorescent with a conventional ballast. So we should see 120 hertz on there. The circuit is described here. We've got 3 volts going in. I'm using one of these little power supply boards that you get with Arduino sets. There is a photoresistor, that's right here. There is a 100 ohm resistor right here that forms a voltage divider with the 3 volts across it. And the oscilloscope is connected across this photoresistor, which will be in like the 2.5K range or something like that, 3K range. Enough that we can measure a voltage across it, because we've created a voltage divider with the 2 resistors. So we now have a light sensitive voltage divider, and so the voltage on there is going to be related to the amount of light that's incident on the photoresistor. And we can see this, a nice sine wave. It's got a little clipped off at the bottom from this fluorescent light here. If I bring it a little closer, we'll see we get a, sorry, that may look very weird on screen, I'm not sure, but we may get a, we can see that the magnitude of the sine wave goes up. So the second question is, well, what about LED bulbs? Both of these have very small bases. They fit into an IKEA fixture that I've got here. Let's put one of these in. Sorry for my arm in the middle. We'll turn that on. Reach the light. I'll shut this one off and see what happens. I'm tilting the light over towards the photoresistor, and we can see the same thing. So we can see that there's really not much smoothing on that. All right, turn this one on a second so we've got some light in the background. We'll take this one out. This one doesn't really flicker noticeably to me, nor does the fluorescent most of the time. Again, sorry about my arm in the way, but this one flickers quite noticeably to me. And look at that. You can see that the waveform is really quite different. It's almost sawtooth. It's spending a lot of time off, I guess. So there's a blanking period which we didn't see with the other two. Now, if you compare to the fluorescent, it's really quite different. I do think I may need to recalibrate my probe. That might be why we're having trouble on the bottom there. But anyhow, I think this is really quite interesting, and I think that this is a sort of proof of concept for setting up maybe a little black project box with a photoresistor and a couple of pins to connect an oscilloscope to try to quantify or get some handle on how different kinds of lights flicker. I noticed that as I now turn off all the lights in here, and I'll turn on some others. I'll turn on another desk lamp. It's a little farther away. There's another light on in here. I'm just going to remove the mic for a moment and reach over here. And you'll notice that that second light seems to pick up some flicker. So that is the light on the ceiling fan above here. Mind you, the fan's also running. Oops, sorry, the scope shut down. The fan's also running, which, well, turning down now. So it does look, let's see, can we change? Okay, so you can see that the ceiling fan light does appear to have a fair amount of flicker in it. That's so noisy a waveform that the trigger is not working very well. If I shade it by standing over there, right, if I shade it from that light, it goes in. But the other two lights in the room appear to be reasonably constant. Anyway, I hope that was kind of interesting. I'll turn this one back on. See a few more jumps around. I hope that was kind of interesting. I'm kind of fascinated by this stuff, and I like the fact that it's possible to visualize it on an oscilloscope with a circuit that really couldn't be much more simple than that. Anyhow, have a good evening. Thanks.